Hello everyone. My name is Shubham Tanode. I'm from IT department. So basically, we will today study about a detailed introduction to K-means clustering in Python. So what is clustering? This was the first question. So clustering is an unsupervised machine learning algorithm that groups unlabeled datasets. In layman terms, we can also say that clustering aims at forming subsets or groups within a dataset consisting of a data points which are really similar to each other, and the groups or subsets or clusters formed can be significantly differentiated from each other. So why clustering? So let us assume that we have a dataset, we don't know anything about it. So a clustering algorithm can discover a group of objects where the average distance between the member data points for each are closer than to the members or the data points in other cluster. So some of the practical applications of clustering are customer segmentation, classifying network traffic, email spam filter, and city planning. So basically, what is customer segmentation? What has it done? There is a some customer behavior has been noted in a large database, and we have to segregate that using clustering so that we get a good insights. So there are different types of clustering algorithms. That one is a k-means, another is hierarchical clustering, fuzzy c-means clustering, density based spatial clustering. So mainly we will be focusing on k-means clustering. So let's start with k-means clustering. So what is k-means clustering? So k-means clustering is an unsupervised learning algorithm used to group the unlabeled dataset into different cluster subsets. Now you must be wondering what is k and what is means. Why does name k means? So usually the putting all of the guesses for k. So k is the number of clusters that are to be formed. So that is k. And as it is a centroid based algorithm, the means in k means clustering is related to the centroid of data points, where each cluster is associated with a centroid. The concept of centroid based algorithm will be explained in the working explanation of k means. So mainly k means clustering algorithm performs two tasks. One is to determine the optimal value of k center points or centroids by a repetitive process, and another is to assign each data point to its closest k center. Cluster is created with the data points which are near to the particular k center. So we'll now study how does k means clustering works. So suppose we have two variables x1 and x2 in a scattered plot. So there are two variables. This is a data set which has been scattered by. So let's take the value of k as a number of predefined clusters. So here it's necessary to know how many clusters we have to form. So let's assume we have two clusters now. So random 2 points, that is k points, need to be chosen from the cluster. No restrictions for the selection. You can select any of the points from inside the dataset. As also here we are considering 2 points. So these are the 2 points which have been in the box. We have selected that. So randomly we select any 2 points. The next step is to assign each data point of a dataset. These are the randomly taken points. They were not in the dataset. As you can see, this is the data set. We have taken 1 point here and 1 point here. So we have to can take at random anything, and we have to just find the distance of each from that point. It's the new point which we have taken. We just usually find the distances. So let's see how does it work. So the next step is to assign each data point to the dataset in a scattered plot to its closest k point. That will be done by calculating Euclidean distance between each point with a k point, and we draw a median between both the centroids as shown in the figure. So let's see the figure. So this is how it is done. So what is, by using some Euclidean method, they find the distance between them, and they find a median center point, and they draw a median through it. As you can see, this is the point and they draw a median through it. So we can clearly observe that the point to the left of the red line are near to k1 and the blue centroid, and the points to the right of the red line are near to k2 or the orange centroid, as you can see in the figure. So now as we need to find the closest point, so we will repeat the process by choosing a new centroid. To choose a new centroid, we will compute the center of gravity of the centroids, and we will find new centroids as below. As we will see this, we will move it using some formulas that as there uses some center of gravity things. So now they will assign each data points to a new centroid. Now we have to repeat the same process until we get until we get the desired output. And above we can see that orange point to the left hand side of the line and the two blue points are right to the line. So these 3 points will be assigned to new centroids. So new centroid. So now we'll keep finding new centroid until there are no dissimilar points on both sides of the line. So we have to find until we get the dissimilar points on both sides. So as we get the dissimilar points, we can now remove the assumed centroids and the two final clusters will be shown in the image given below. So this is how it has been segregated. So now we have studied the K-means algorithm and various steps involved to reach the final destination of differentiation of clusters. But here we have assumed the value of K. So how to find the value of K? So for that we use elbow method. So what is elbow method? Let's see. The elbow method is the most popular in finding optimum number of clusters. This method uses WCSS, that is within cluster sum of squares, which accounts for the total variation within the cluster. The formula for WCSS is given here. You can just take a look over it. In the formula above, where summation of pi in a cluster 1, distance pi ci square is the sum of square of the distance between each data point with its centroid within the cluster 1. Similarity for other two terms in the above formula as well. So what are the steps involved in the method? So k-means clustering is performed for different values of k, that is from 1 to 10, and WCSS is calculated for each cluster that is formed. The curve is plotted between WCSS values and the number of clusters. The number of clusters. Curve is plotted between WCSS values and the number of clusters k. The sharp point of the bend or the point of the plots looks like an arm. Then that is the point considered the best value of k. As you can see, the graph has been plotted as they said the arm. So this is the arm, the point which is like which actually looks like, and then the point which is considered the best value, the sharp point. This is the sharp point and we consider this as the optimal number of clusters. Let's dive into the code. So we'll use Google Colab to run our code. So we will import all the libraries that we will be needing in for this project. So there we will need NumPy, Pandas, Matplotlib, and the more we need, we will import it on that way. So first we will read the data set. So for reading data set, we have this following command in Python, and I have here, this is my file location where I have stored my data. I have stored in the drive, and I have access through drive. So for this data set, I will provide you the link. First, I will show you the data set. So this is the data set I am using for this project. So we will firstly read the data set, then we will extract the independent variable. So for extracting variable, we have this code. Then we will import k-means from sklearn cluster. Now for initial value, we need the value of k. So for that, we will use elbow method. For that, we will first initialize the list for the values of CSS. That is, we'll initialize an empty array to it. Then we will iterate it for the value of 1 to 10. So for in range 1 to 11, that is 10 values, we'll use k-means is equal to k-means. This is what we have imported, k-means, in which we have to give some values for initial clusters. So clusters and clusters is equal to I, and I values from 1 to 11. So init is a function which we initialize k-means plus plus, that it adds in an init, and max iter is equal to 300 and random state equals to 0. Now if we feed the value of x in k-means, and then we append the values in k-means dot inertia. This is the field. Then we plot the graph from range 1 to 11. The title given to the graph is elbow method, and the label is number of clusters k, and y label is WCSS list, and plt.show is a command to show the graph. So you can see this is the graph that has been plotted. So as we can see that here we have a sharp bend at this point, so the cluster is 3. So now as we know how many clusters we have, so now we will train our k-means model on the data set. So for training, we use the k-means. Then the same way, we give the values for the clusters. Init is equal to k-means plus plus, and init is equal to 10, max iteration 300, and random steady is equal to 0. Now we will predict. So we will predict using k-means dot fit predict x, as we know the values of x. So now when we have trained the dataset, we will visualize the cluster. So for visualizing, so there are 3 clusters. So for so using PLT, we can plot the graphs. So you can see this for plotting, as we have to visualize it. So we will give the 3 clusters 3 different colors, that is blue, green, and red. And for the centroid, we will give different color, that is yellow. And we will plot that visualization, and we will see how it has been seen. So let's see. So this is what we get, the final output. So these are the 3 clusters, and these are the centroids that we get, that all centroids for all value of 10. So 1 2 3 4 5 6 7 8 9 10, as for each value of k is equal to 1 to k is equal to 10, we have find the centroids, and then we have segregated the data. That's it. Thank you.